Hey there and welcome. If you've ever gotten your hands on some real-world data, you know the feeling, right? It's chaotic, it's inconsistent, it is anything but ready for analysis. Well, today we are going to turn that chaos into clarity using the absolute powerhouse that is the Pandas library in Python. Let's get right into it. So you gotta ask, why is data so messy to begin with? Well, it's coming from all different sources, it's being typed in by humans who make mistakes, systems have glitches, the list goes on. And the result is a data set that feels more like a puzzle than a resource. But hey, every puzzle has a solution, and that's exactly what we're here to figure out. Just take a look at this. This is reality for so many of us. We've got missing ages, just kind of floating there as NaN. In the city column, capitalization is all over the place. And look, a completely identical row for Bob, a total duplicate. And that age column? I'd bet you anything it's being stored as text instead of a number we can actually work with. This is our starting line. So here is our game plan for today. First, we're going to tackle the great cleanup, just fixing that foundational mess. Then we'll move on to bringing order to data, which is all about sorting and structuring. After that, the really powerful part, reshaping for analysis. And to wrap it all up, we'll pack everything into your data toolkit. All right, let's dive into Act 1, the great cleanup. This is where we roll up our sleeves and really attack the most obvious problems head on. Getting this part right is absolutely crucial for everything that comes after. Okay, so first things first, those pesky missing values. You can't fix what you can't find, right? So step 1 is all about detection. One simple line of code, df.isNull.sum, and boom, you get a full count of every missing value in every single column. Once you know just how big the problem is, then you can move on to step 2, figuring out your strategy. And that strategy really comes down to one big choice. Do you remove or do you replace? So on one hand, you've got drop in A. It's like a surgical scalpel. It just cuts out any row with missing data. It's super fast, but you risk throwing away some really valuable information. On the other hand, there's fill in A. This is more like a restoration project. You can fill those empty spots with a 0, or maybe the average of the column, or even the value from the row right above it. It's all about preserving your data. You ready for some quick wins? Let's do a little rapid-fire round. You got duplicate rows? One command, df.drop duplicates, and they're gone. Inconsistent text? Just chain together .str.lower and .str.strip to make it all uniform. And that age column that's being treated like text? df.age.sttypeint. Just like that, it's a number. 3 simple lines solving 3 huge problems. But here's the thing, not all type conversions are created equal. You gotta know which tool to use. For simple stuff, .astype is your go-to, your general purpose tool. But for something tricky like dates, you need a specialist, and that's PD2 datetime. This thing is brilliant. It can look at dates written with slashes, dashes, month names, all sorts of crazy formats, and it intelligently figures it all out. Okay, take a breath. Our data is officially clean. That was half the battle. But now it's time for Act 2, bringing order to data. We need to organize what we've cleaned up. This part is all about creating a logical structure that's easy for us and for our computers to read. The simplest way to create order is, well, to sort. With one line, df.sort_values, age, we can instantly arrange our entire data set from the youngest person to the oldest. Just like that, some of that chaos starts to look like a coherent list. But what happens when you have a tie? Like, what if you have a bunch of people who are the exact same age? That's where multi-level sorting comes in. By passing a list of columns, first age, and then salary, Pandas will sort by age, and then for everyone who's the same age, it'll use salary as the tiebreaker. It's a really powerful way to create a deeply nested logical order. Sometimes just sorting isn't quite enough. You actually need to assign a rank, like first, second, third. The .rank function does exactly that. Now, by default, if you have a tie, it can get a little weird, averaging the ranks. That's why the method equals dense option is so incredibly useful. It gives any ties the same rank but doesn't skip the next number. So you get a nice clean sequence like 1, 2, 2, 3. And finally, let's just add some final touches to make our data frame genuinely easy to read. You can rename one column with df.rename, or hey, just rename all of them at once with a new list. And, maybe most importantly, you can reorder the columns to put the most critical info right at the front. It's all about getting the data prepped for its final transformation. And that brings us to the grand finale. Act 3, Reshaping for analysis. This is where things get really cool, because we're not just cleaning or sorting anymore. We are fundamentally changing the shape of our data, switching between what we call wide and long formats to unlock some incredible new ways to analyze it.
So first up, let's talk about melting. Now, I want you to think of it like taking a wide, chunky spreadsheet and just melting it down into a long, flowing list. Instead of having a bunch of different columns for your measurements, we unpivot them so that every single measurement gets its very own row.
So here's a classic wide format table. Totally normal, right? We've got one row for each student, and then their scores for math, science, and English are in different columns. It's really easy for our eyes to scan, but for a lot of plotting libraries or statistical models, this format can be a real headache.
And this one line of code is the magic wand that makes it all happen. What we're telling Pandas is, hey, keep the name column as our main anchor, and then melt everything else down. Take those column headers and put them in a new column called subject, and take their values and put them in a column called score. And voila! Here is the result. Our data is now in what we call a long or tidy format. Every single row is now a single observation, one student, one subject, one score. This structure is so incredibly powerful because now it's super easy to group by subject or to plot scores over time.
Okay, that's awesome. But what if you need to go the other way? What if you need to pivot back to that wide format, but your long data has duplicate entries? Like, say a student took the math test twice, what then?
And this is where a lot of people get stuck. They try the simple pivot function, and it throws an error. It sees a duplicate and it just doesn't know what to do. But that's where pivot table comes in. It's the robust, real-world solution. It has this agfunc parameter that lets you tell it exactly how to handle those duplicates, like say, by calculating their average. And here is the payoff. Pivot table sees those two math scores for Alice, and instead of panicking, it just does exactly what we told it to do. It averages them and presents one single, clean entry in our final Y table. It just elegantly solves that whole duplicate problem, giving us a perfectly summarized, analysis-ready view. So we've gone on quite a journey, from a complete mess to a perfectly structured data set. Now let's bundle all of this up into a simple, repeatable toolkit that you can use every single time.
You know, when you boil it all down, it comes back to this simple 3-step workflow. Step 1 is always clean. Fix all those foundational issues, missing data, duplicates, wrong types. Step 2 is order. Sort and structure your columns so everything is clear. And finally, step 3 is reshape. Use melt or pivot table to get your data into the perfect shape for whatever analysis you have planned.
At the end of the day, cleaning data isn't just some technical chore. It's about preparing your canvas. Now that your data is clean and it's ordered and it's properly shaped, it's finally ready to reveal its secrets. So the real question is, what story are you going to tell with it?